All right, we're moving on to dividing monomials. And we are in lesson 5.2. We are dividing monomials. Remember, a monomial is a polynomial with one term. Our essential question is, can you simplify quotients, something that's being divided, of monomials, to find the GCF of several monomials? So you don't have to write this down, but the property of quotients, if A, B, C, and D are real numbers, with B not equaling 0 and D not equaling 0, why can't B and D equal 0 here? Because remember, anytime you have 0 in the denominator, then it's undefined. So this is telling us that AC over BD can be split up into two fractions, AB times CD. And notice if I have BC over BD, notice those B's can just cancel out, and I have an answer of C over D. The B's cancel out. So we're going to start very simple, and we're just going to simplify example 1. What can go into 24? That can also go into 36. Good. I know that we could split this up into 12 times 2 and 12 times 3. And the reason I'm showing you like this is the 12s cancel out, and we get 2 over 3. Now, you've done a ton of simplifying, and remember, for answers, all answers have to be simplified fully. But what happens if all of a sudden a x and a y are thrown in there? Okay, what can go into 16 that also goes into 18? So I'm going to split this up into 2 over 2, because I know that 2 times 8 is 16, and 2 times 9 is 18. And then I'm just going to show my xy over x. So we're going to cancel out things that are in common, 2 and 2, x and x. So my answer is 8y over 9. Now, could I do that by just reducing 18 and 16 by 2? For sure, we could do that. And cancel out the x's, for sure. And you're going to get the same thing, but sometimes you guys miss what's left over. So try not to miss that. Now, there is a rule. Whenever I have the same variable, and notice I have 8 in the numerator and 4 in the denominator, we are going to subtract them. Okay, so I just tell my students, hey, we're going to go where the larger number is, so I know that's on top. So I'm going to solve this for x, and I'm going to take 8 minus 4 and put it where the larger number is, which is x to the 4th. Now, if we get to the logistics of this, we know that we could write x to the 4th as x to the negative 4th in the numerator, because anytime you move something from the denominator to the numerator, you're going to put a negative in the exponent, or vice versa. Okay, but remember, when I multiply the variables, I add the exponents, and I get x to the 4th. I find that my students like to see, oh yeah, 8 is the greater number, so we're going to put it on top. This would be over 1 if I wanted to show that. And we're just going to subtract. 8 minus 4 is 4. So I like this way. But if you like to see the logistics of it, go ahead and show the negative exponent. And here are those rules, the rules for exponents for division. Obviously, this is starred because this is important. This is one of those laws of exponents. If m is greater than n, a to the m over a to the n equals a to the m minus n. If n is greater than m, a to the m over a to the m, n, equals 1 over a to the n minus n. So notice we're putting it where the greater number is. So in this case, n was greater, so we're putting it on the bottom. In this case, m was greater, so we're putting it on the top. And if they're equal, they are just going to equal 1. So let's knock a couple of these out. Will this go on top or bottom? Good. It will go on bottom, and when I subtract, it is b to the 4th. Well, don't forget to put that 1 on top. These are the exact same thing. I know these fully cancel out, and I saw the formula. It says it's equal to 1. Top or bottom, so we're looking, is 7 or 4 greater? I know that 7 is greater, so I'm going to put them on the top. C to the third, 7 minus 4 is 3. And last one, top or bottom, they're going to go on the bottom, x to the 5th. Don't forget it's going to be 1 over x to the 5th. All right, for my last question here, they're asking us for the GCF. Well, if I'm looking for the GCF, I have to break down those numbers first. So I'm going to start by breaking down 21 and breaking down 6. So I know 21 is 3 times 7, and 6 is 2 times 3. Well, I do notice that there's only one number in common, so the GCF for the number has to be 3. Now, I can do the exact same thing with the x's and the y's, so I'm going to write those out. I'm actually going to erase this little area right here. I tried to erase, but that didn't work, so I'm going to go ahead and I'm going to write this in purple over here. So I have 3 x's for the 21 x cubed y and 1 y. In the 6, x to the 6, I have 1, 2, 3, 4, 5, 6 x's and 3 y's. So let's do what we did and let's circle what's in common. I have 3 x's in common and 1 y. So I know the GCF is right here. And since I have 3 x's in common and 1 y, the GCF is 3x to the third y. Now, if you want a little hint, keep listening. Do you see that x to the third and x to the sixth, that I took the one with the smallest, x to the third? So I tell my students the greatest common factor has to be the least amount of variables, the smallest one. Why? Because x cubed has to go into x cubed has to go in x to the sixth. So notice I took the smallest. And look here, I have y to the first and y to the third. Notice I also took the smallest because this y is just representing y to the first power. And the last thing I have is a mega challenge for you. So I'm just going to go through this question. I like to draw my vinculum first. So notice I'm drawing it in teal. And then I just like to reduce the numbers as we can. How can negative 24 and 32 reduce? Good. We know that they can both reduce by 8. So I have negative 3 over 4. Then I like to look at the x's. Will the x's go on the top or the bottom? They will go on the top, and I just subtract 3 minus the invisible 1. Y's. Will the y's go on top or bottom? Good. They will go on top. 5 minus 2 is 3. Z's. Will z's go on top or bottom? They will go on the bottom because 4 is larger than 1, but 4 minus 1 is 3. Great job with that challenge.